Okay, here we go. Number 11 on circles, tangent lines, and area. We're given this information. It's going to be a performance task or an assessment at the end of the week. The idea is you're trying to find the distance from A to B, given that you have two circles with two tangent lines. TK is a tangent, okay, and then down here is a tangent, but it's not going to come into play with this particular problem. But you can kind of flip this whole thing over and picture it's a mirror image of each other. That's kind of important. Circle L has a radius of 20. Circle R has a radius of 11. The distance from T to K to those 2 points of tangency, there's a point of tangency here and here. Remember, tangent lines are 90 degrees to the center of the circle. Okay? And I think that's about it. So with that given information, we can start to solve the problem, kind of map it out. I think it's important to know that to recognize that there is a rectangle here. So if this side is 40, then the property of a rectangle says this opposite side right here is also 40. And then if you have a radius of 11 here, that means that's 11, and the opposite side is 11. And if the radius here is 20, 11 plus what? Or 11 plus 9 is going to give you 20. So then if you can kind of think of it like a shape within a shape. So now you have like this shape in here that I'm shading. You can kind of envision that. That's a right triangle. So I have this right triangle. And I think the trick is to locate where the right angle is and label the parts. So if there's my right triangle, this side is 40, this side is 9, and this side over here is the distance between L and R to the two centers of the circle. So if I use Pythagorean theorem, a squared plus b squared equals c squared. Substitute what I know. So this is 9 squared plus 40 squared is equal to whatever the distance between L and R is squared. So a couple ways to do this, maybe on your calculator. One is you could simplify this and do 81 plus 1600 equals LR squared. And then you have 1681 is equal to LR squared. So the distance from L to R is the square root of 1681. And then you can punch that in your calculator. Square root of 1681 LR equals 41. Then there's a little calculator method you might want to try here. Right away, you could just take the square root. So another alternate to doing this, at this point right here, you could decide to square root both sides. So you have LR is equal to the square root of 9 squared plus 40 squared. So if I were to punch that in my calculator in one step, square root of 9 squared plus 40 squared, close my parentheses, get the same result. Save you some time on things like SAT and the like. So the distance between L to R is 41. Okay. Knowing that we have a radius over here of 20 and a radius over here of 11, that accounts for, you can kind of picture down here on our drawing, this 20, this is 11, obviously not drawn to scale. The remaining part, that counts for 31 out of the 41. So this middle portion, what's left over, is 10. So the distance from A to B is 10. Because 20 plus 10 plus 31 equals the entire distance, 41.